We welcome Giovanna Tinetti. She's the PI of ARIEL. ARIEL is chosen as the new ESA mission for exoplanet research. Next to Giovanna is Joe Barstow. She's a planetary scientist from UCL. And we welcome Michiel Min. He works at ASRON in the Netherlands as an exoplanet scientist as well. And ARIEL's been selected as ESA's next medium class science mission. It will be launched in 2028. Can you tell us something about it? What will ARIEL going to do?
Yes, we're very excited about this selection because ARIEL will allow us to analyze the atmosphere of about 1,000 planets in our galaxy and understand all the chemical composition, what these planets are made of, what's the weather like there, really understand a little bit how planets are forming and evolving in our galaxy.
Yes, one of the things that I'm most interested in is it will give us the opportunity to compare the exoplanets and their atmospheres, and particularly their clouds orbiting other stars, with the planets in our own solar system. Until we sent spacecraft to directly observe the planets in our own solar system, our predictions were actually quite often wrong. So this is our first opportunity really to classify many planets around other stars and to see how unique the planets in our own solar system are, or if actually they're quite representative of what we see out there.
Yeah, so what I'm very interested in is then, once we have all this compositional data, right, we know what the planets are made of, to try to link this back into how these planets formed and how they evolved, right? So you can imagine if you have different forming conditions, you lock up different elements in the core of the planet or in the atmosphere of the planet, and if we can then try to see from the planets what they are made of, we can try to link this back to how they formed and what they formed from.
Could you tell us, because I know this is the first mission to really study such a huge sample of planets, or at least the chemistry of such a huge sample of planets, could you tell us how that happens? Because we're not talking about planets we can see directly, that's right? So, is that right? So.
Yeah, so the mission, what we'll do, will not necessarily see directly planets. What we will do is to analyze the light, and in particular the light of the star and the planet together, and we'll be able to separate those two using a technique that is called transit, that has been used very successfully so far. And through the analysis of this light, we'll be able to understand whether there are some chemical species in the atmosphere and what's going on in these very faraway planets.
ARIEL will observe 1,000 exoplanets in the range from Jupiter's to super Earth-like sizes. But how can we find a sister of planet Earth when you're only looking at the hot and planets which are near their stars?
Well, we certainly want to concentrate on planets which are very diverse, and so not necessarily similar to our own planet, more to put our solar system in a bigger context, like Joe was telling us before.
So, would you say that, could you envisage after ARIEL goes up, and assuming it's a big success, that you might in, say, a decade after that, imagine a probe which could analyze the chemistry of Earth-like planets, if there are some more out there to be found? Is that something that you see as a long-term goal?
Definitely, I think so. And in fact, there are mission concepts on the table for sort of NASA's next decadal survey looking into that more distant future that would be capable of doing exactly that. These would be sort of super Hubble, super James Webb style telescopes, big observatories. They wouldn't just be for exoplanets, but they would be capable of looking for habitable zone, terrestrial sized planets, and seeing if there are any out there that are like the Earth.
There will be ground-based observatories like the ELT, which will be online in 2024. It's also looking in optical and infrared. What's the difference?
What's the difference? With a space-based observatory like this, we are not hampered by our own atmosphere being in the way of actually doing the detection, right? You can imagine if you want to look for water vapor, it's not very easy if you have to look through a huge column of water vapor in our own atmosphere. So that's why a space-based mission like ARIEL is really very convenient. What the ELT will do in the context of Earth-like planets, but that's also future, that will first characterize on the atmospheres of Earth-like planets, doing, well, very fancy tricks trying to get our atmosphere out of the way.
So as a general philosophical point, so we're building enormous telescopes on Earth, we're launching more and more space missions to understand other solar systems. What's your personal view on how long it will take to find that Earth 2.0? We hear this a lot, you know, NASA talks a lot about finding Earth-like planets, and my hunch is we're not quite there yet. Do you think maybe a decade, 2 decades, or will we be surprised? Will it be sooner than that?
Well, the question is whether we really want to see something that is so similar to us, and that is the only interesting question. And to a degree, that's why we need to have missions like ARIEL that tell us how diverse are all these planets and if there are other possibilities. And so just going straight to something that is very similar to the Earth, it means that we're not learning during the journey. I think it's very, very important to get the big picture before you get to something that is closer to us.
Yes, I'd agree with that. I think some of the things out there that are actually the most interesting at the moment are Earth-sized planets that have a similar sort of temperature to the Earth, but they're orbiting stars called M-dwarfs that are much, much redder than our own sun. And so even in this session today that we've been attending, some of the interesting science is that because the stars are so very different from solar-like stars, their atmospheres are likely to have evolved in a completely different way. So they may potentially be habitable, some of them might even host life, but their atmospheres are not actually that likely to be strictly Earth-like. And that's something that we can start to look at actually probably over the next decade, or at least the next 20 years.
Oh yeah, I'm Josh Hadrigo from New Scientist. One thing I've heard a little bit of chat about at this conference is clouds, not on Earth, but in the atmospheres of exoplanets. How worried are you guys about that? Is there a chance that that's going to scupper this whole thing, and if not, then how are you going to deal with the clouds if you encounter them?
Can I say something? So clouds are can be annoying because they can just flatten and mute out the features of the gas species that we want to see. But if you treat them properly, if you understand how these clouds form, you can actually also use them as a tool to learn something about your atmosphere. So, for example, you can learn things about the dynamics of the atmosphere. If you see clouds, that means that it's not only raining out, but it's also mixing up. So that tells you something about how dynamic your atmosphere is. So if you and this is what we're doing here. Actually, we're trying to understand clouds so that we can use them as a tool instead of just as a nuisance on our observations.
Perhaps to add on this, I think one of the unique selling points of ARIEL is to be able to look at light that goes from the optical light, the one we see, down to the infrared, that normally it's where atmosphere are more transparent, and so that gives us the ability really to have either more techniques really to see through these atmospheres that is necessary.
Yes, and in fact, looking at the solar system, every substantial atmosphere in the solar system, every single planet that has a substantial atmosphere, it has clouds as well. So there is no reason we would expect to see planets that don't have clouds particularly. Clouds should be the norm, but they're going to be very, very different clouds on hot Jupiters compared with the ones in the solar system. They're going to have very interesting chemistry. People talk often about glass rain. There have been some lovely press releases over the last few years. Ruby clouds is another nice little press release title, but all of that aside, there is a lot that they can tell us about the chemistry and the dynamical processes on these planets.
So I guess we should bring this to a close in a second, but I guess one final question from me. What are you three of you most looking forward to from this mission? I mean, it must be very exciting. It's been approved. It's a European mission. It's a great example of international science, but what are you going to be looking for in the next few years?
Well, scientifically speaking, I'm really looking forward to see all these atmospheres and try to understand whether they are correlated somehow, understand the big picture. But also from a human perspective, I'm really looking forward to work with many scientists in many countries that are in Europe and elsewhere, because I really think it's important to have all this big team on board to make a leap in our understanding.
I think ARIEL is going to do for exoplanets what Kepler has done for exoplanet detection. ARIEL is going to do that for characterization. It's the first thing that can really give us large number statistics that can really enable us to start saying these kinds of planets are common, these kinds of planets are unusual or rare. At the moment we don't know that because we only have a few that have been characterized. So that's the most exciting thing for me.
Yeah, I think I can only agree with that. So we know now of 4,000 planets, and we only have, for a handful, we have some information on the atmosphere to make that difference, that you can do statistical correlations. I think that's going to be amazing. Yeah.
Well, I think this has been great, and thank you so much for coming here and talking to us. It's a fantastic time to be in this field, I guess. And thank you once again, and thank you to everybody out there for listening and
thanks for joining
as well.